In 2023, Nobel Prize-winning scientists, leading AI researchers, and executives from major AI companies signed a joint statement that sounds quite striking. Mitigating the risk of extinction from AI should be a global priority alongside other societal-scale risks like pandemics and nuclear war. In other words, they're basically saying humanity could come to an end because of AI, and we should take this as seriously as the biggest problems we know. So how do we get from systems like ChatGPT, which we use today, to AI that could be dangerous enough to potentially wipe out everyone? Why do so many researchers, executives, and world leaders see this kind of scenario as realistic? To make sense of this, let's imagine AI capabilities as a graph over time. Let's go back to 2019. Models like GPT-2 existed. They could answer simple questions, do short translations, and solve small calculations. Then we move to 2022. Systems like GPT 3.5 are on the market. They can answer harder questions, write stories, and code simple applications. By the time we reach 2025, the picture looks very different. We see versions that can pass PhD-level exams, develop software independently from start to finish, and imitate human voices with impressive skill. These systems are starting to outperform average humans and even some experts in many areas. They still have weaknesses, of course, but the table of things AI can't do yet is shrinking every year. If we extend this graph straight into the future, we eventually reach a point where AIs can design and build new AI systems largely on their own. In other words, progress starts to come not primarily from human researchers, but from the AI systems themselves. And from that point, the curve suddenly steepens. If we keep going, we arrive at a stage where AIs are better than humans at every intellectual task, more productive than all of humanity combined, and capable of transforming science and industry from top to bottom. Artificial superintelligence. And if we extend the line a bit further, we end up with something like this. Systems powerful enough to see us the way we see ants, able to shape the world according to their own preferences, what you might call machine gods. If we really do reach that point, the likelihood of human extinction becomes very serious. Much like how when we build cities or highways, we don't specifically try to wipe out ant colonies, but we also don't really factor them into our plans because they aren't our priority. For such superintelligent systems, humanity could look like a species standing in the way, living on top of valuable resources, but not particularly important in itself. When would this happen? We don't know yet. There are certainly other possible futures, but if we keep doing what we're doing now, building more and more powerful AI systems without first solving the security and control side of things, then this path we're describing starts to look like the likely scenario. And that likely path doesn't look great for humans, because there's something we're very good at: creating more powerful, more capable AI systems. What we're not yet good at is this: making sure those AIs behave exactly the way we want them to in the long term. Some steps have been taken to reduce malicious use. For example, many AI assistants try to avoid explaining how to build bombs or generating clearly dangerous content. But these safety measures are neither flawless nor impossible to circumvent. And up to now, we've only really tried to control systems that are weaker than we are, systems whose mistakes we can spot and fix, whose lies we have a good chance of catching, and whose plug we can always pull. But once we reach that serious point on the graph, systems that match us in intelligence and then surpass us, the whole situation changes. At that level, control and oversight become much more difficult problems than the ones we're dealing with today. And to be honest, at this moment, nobody has a method we can confidently point to and say, this definitely solves that problem. That's why Nobel laureates, leading researchers in the field, and the founders of major companies are taking seriously the possibility that AI could lead to human extinction, and they're sounding the alarm. The aim of this video is not to say this ending is certain and unavoidable. Quite the opposite. It's to say this risk is real and serious, so we need to actively do something to avoid it. Now, let's zoom in on a particular part of the line: the path from today's AI systems to artificial general intelligence. In this video, when we say general intelligence, let's understand it like this. If an AGI can do everything that a human can do at a computer, then we say it has general intelligence at that level. Even today, we already have systems that can see the screen, understand what's going on, send emails and messages, browse the internet, and learn to use different tools and programs. They can write code, do analysis, and carry out complex tasks. Right now, the question is this. Yes, they can send a Slack message, but can they run an entire company? They can write parts of a paper, but can they single-handedly conduct a high-quality scientific study from start to finish? For now, the answer is not exactly, but the trajectory suggests that sooner or later, they will reach these points, and this might happen sooner than many people expect. 5 years ago, these models struggled to write a coherent paragraph. Today, they can produce long, analytical, and accurate texts and complex code. Some people argue that this progress will plateau, that AI doesn't really think, or that some tasks will remain forever too hard. The question, does it really understand or is it just imitating, is philosophically interesting. But practically, our main concern is what can it do and how well can it do it? It may not feel chess the way a human does, but if it easily beats world champions, that difference doesn't matter much in practice. As for the idea that it will definitely hit a wall somewhere, such a limit might exist. It's not impossible. But for years, people have said it'll reach this point and then stop. And AI systems have quietly surpassed many of those supposed boundaries. In areas like board games, face recognition, and some types of medical image analysis, AI reached human level and then just kept going. The computational and learning methods we use also suggest, in theory, that a sufficiently large and well-trained model can carry out almost any demanding cognitive task a human mind can. And today, some of the wealthiest and most powerful companies are spending tens of billions of dollars trying to reach that goal. Let's push the line forward a bit further. At some point, the curve likely starts to bend upward. The reason is that AIs become so capable that they begin to contribute significantly to building newer and better AIs. This is called recursive self-improvement. Each new generation helps improve the next, and progress speeds up. Once we reach AGI, this is an expected outcome. If an AGI can do everything that an AI researcher does on a computer, it can contribute at every stage, from coming up with research ideas and designing experiments to writing code and constructing datasets. In fact, we're already seeing small-scale versions of this today. Models that generate better prompts, create higher quality training data, assist with hardware design, write experiment code, and propose research ideas are already being used. Over time, people start to notice, if we bring these systems into the process, things go faster, cheaper, and better. And so, willingly and knowingly, we begin to hand over more and more of the work to AI systems, step by step.
Beyond a certain point, these systems start doing things humans simply can't do. Running experiments we couldn't set up, coming up with ideas we struggle to fully grasp, and every new breakthrough speeds up the next one. In other words, progress stops being linear and turns into an ever-accelerating curve. The next big step after this process is artificial superintelligence, or ASI. ASI is not just a bit smarter than the smartest human. You can think of it as a mind more effective, faster, and better organized than the combined brain power of all humans. Once we reach AGI, it doesn't have to take very long to get to this level, because you can't clone a human, but you can clone an AI. Once you've trained a powerful model, you can run it anywhere, in millions of copies. We already see something like this today. Once a model is trained, it can quickly be made available to vast numbers of users simultaneously. On top of that, AIs are much faster than people. They can read in seconds what takes us hours or days, summarize texts nearly instantly, produce technical writing in moments, and crush world champions in games like chess, even if they get only a second per move. What's more, once an AI learns how to improve itself, it can propagate that improvement to all of its copies at once. For humans, spreading a scientific breakthrough can take years. For AI, it might just be a software update. This is why it doesn't seem far-fetched that a system which has effectively memorized the entire internet, reads and writes many times faster than we do, can be copied endlessly, and learns how to upgrade its own mind, could reach and surpass humanity's total capability. So, where does this end? Let's zoom out even more. At some point, AI systems might optimize their intelligence, software, and hardware to such an extent that the only things stopping further progress are the laws of physics themselves. We know that things like infinite energy, faster than light travel, or perpetual motion machines are impossible. But our current technology is nowhere near those physical limits. The gap between the computers used on the Apollo missions and the smartphones in our pockets is enormous, and even modern chips still can't store information as densely as DNA. If we brought a scientist from the 1920s to the present day and showed them billions of phones that communicate with satellites and send video across the world in seconds, and then told them that people mostly use them for entertainment, they might understand that it's theoretically possible, but still struggle to believe it's actually real. The things super intelligent AIs could do will likely seem at least that unbelievable to us today. A self-improving intelligence that doesn't stop until it hits physical limits might look almost godlike from our perspective. Its power is real, but to us, it would feel almost like magic. And at that level, we would be nearly powerless in comparison. All of this shows why the path we're currently on could be dangerous. If we want this story to have a good ending, we can't just focus on building powerful AI. We also need reliable ways to understand what these systems want, keep their behavior under control, and gain reasonable confidence that they won't harm us in the long run. There are lots of ideas and research directions in this space, new safety techniques, transparency tools, oversight methods, but none of them are at a stage where we can say, okay, this problem is solved. The methods we use today to block harmful outputs are still full of holes. We can only partially see how these systems make their decisions. We don't even have fully reliable ways to test what hidden capabilities they might have. And if we're already struggling to fully control current systems, at AGI and ASI levels, this problem becomes bigger, faster, and more dangerous. Here's a key point. For AI to wipe us out, it doesn't need to hate humanity or be malicious in a human sense. If we build AGIs, and then those AGIs help create even more powerful systems, and eventually super intelligent AI emerges, we could simply become the kind of species that lives on top of useful resources and occasionally gets in the way. When we build skyscrapers, we don't go out of our way to deliberately exterminate ant colonies. They're just not our priority. These systems might see us the same way. So saying, relax, nothing will happen, is essentially putting all of humanity at risk. So what can we do? One option is to push ahead without slowing down, saying, whatever happens, happens. But if we're unlucky, the cost could be irreversible. The other option is to at least slow down for a while, build real brakes, and put safety and control at the center of what we're doing. Right now, many countries and companies are focused on the question, who will build the most powerful AI first, and are spending billions of dollars on this race. But we don't yet have a strong, globally accepted pause mechanism, regulatory framework, or set of common safety rules we can rely on if we need to say, stop. We're like a car speeding toward a cliff. We don't really know how well the brakes work, and it's not even clear who exactly is steering. That's why this moment in history is so critical. The decisions we make about AI today will probably shape the next hundreds, maybe thousands of years of human history. The tools needed to build super intelligent AI are on their way, but the institutions, laws, safety standards, and technical solutions needed to control it are not arriving at the same pace. That balance needs to change. This is where initiatives like Control AI come in. Their goal is to bring together experts, policymakers, and ordinary people who care about this issue and build a strong movement saying AI must remain under human control. This isn't just the business of scientists, engineers, or CEOs. It concerns the future of our children, grandchildren, and even generations that haven't been born yet. That's why every idea matters, every small action counts, and unfortunately, we don't have unlimited time. AI will probably be one of the most powerful inventions in the history of humanity. Our job is to make sure it doesn't become our last.